Hello aspirants, in this video we will understand Angular signals complete introduction. This will cover and understand why signals were introduced in Angular. Also, we will compare Angular signals with RxJS, and then we'll see a real world usage patterns with signals, and then we will understand how Angular signals simplify reactive state management system. So first of all, we'll see what are the problems we have been faced before signals. So Angular applications mainly relied on RxJS operators, observables, and then behavior subject. For a simple state management often become verbose. For async pipes, we have been heavily used in across templates. For a local UI state, how it is, I have a sample code and I'll show you the live example in VS Code as well. So suppose we'll see uh, a counter example, which is a behavior subject type definition, and then we have an increment function which I wrote, and then we'll see an async pipe. Okay, so I have a local sample app, and then I will show it into the browser. I have defined a counter, which is a behavior subject. It's an observable, and then one increment function which I already showed you that I have already copy pasted. So this function will be binding to the counter. What it shows is there is an increment function with a button. When I click on the button, that counter should increase. So that is the main logic which we wrote in this counter example. So it will run in the browser. So we have wrote two functions, increment and decrement. One will increase the value by one will decrease the value by 1. What will happen is with this behavior subject uh, before signals, it needs a behavior subject even if it is a simple counter, and it needs a next function to execute, and then a value accessor which needs to be executed. And also after the change of value accessor, so a subscription is needed, and then to render the value in the HTML template we need an async pipes. So this RxJS is powerful, but sometimes it is heavy for simple UI. If we see, I wrote two methods, increment and decrement, which is being binded in the HTML as well for an Angular application. You see plus and minus I wrote. So the value will come. What I said is with this behavior subject, all these problems will occur when we use behavior subject before signals. And then there is one more problem we have been faced with, change detection. So this change detection in Angular is relied on zone.js. That means whenever there are some inputs changed on push, that change detection will be occurred, and then border detection cycles. The signals introduced fine-grained reactivity, and only UI updates are triggered. That means it is simple in execution, and then before that itself, it will get the value, and it will not burden the application. That means it will not burden the execution of the application. Okay. So definition of the signals. So before coming to this signals, uh, we'll see this again. So Angular heavily relied on Zone.js for the change detection reference and broader change detection cycles with ng on changes. We'll see whenever the input changes happen in components. So to overcome these, signals were introduced and with the fine-grained reactivity, and then only UI related updates will be triggered. So no other logic will be triggered on rendering or on changing the value of the particular signal. Then we'll see the actual count variable which have been defined, and then with the signal. So the logic which I have already defined here, so that we will mean copy paste. For the time purpose, I just made it. Whenever we define a variable with the signals, we don't need a async pipe. Okay, that async pipe will be converted like this with a function calling variable, and then we have been imported this async pipe, right? I just commented this code. Okay, the code has been now increment decrement. We just need to update the value whenever there is an increment or a decrement. The count dot update, this means count dot set update bind. So there are some other functions. So we'll be updating the value, right? So that update will happen here. What we should see is there is no next call, there is no value accessor call, there is no subscription somewhere else. All these things will happen whenever we update a value here. That should bind to the UI, and that should render the new value. So the count, actually this count is 0 initially, and then I clicked increment, I clicked decrement. Okay, which is happening with the calling of count. That means this calling of count, wherever we are calling here in the HTML template, so this will be depending on the signal, and the logic will execute whenever the value will be changes. That means the Angular template depends on the signal, and Angular tracks depends automatically whenever there is a value change. We see this one, we wrote this in a HTML template. So that means the only dependent UI section renderer will be tracking the change detection. This improves performance and predictability of the value changes. When we go to the signals, so the flow will come like a value of signal changes. Angular tracks the dependency, and only related UI updates will be happened. That means there is a counter. I mean, I have been given only count variable for small introduction here. There is some more some other variable. It has been already defined. That means it's not a count. It's a flag. So if the flag is being changed, then internal to that flag, inside of that flag, whatever the HTML template is there, that will be rendered again, that the value will be changes depending on the flag, because that is a signal. So like this, signals were introduced, and then there is the next part in signals is computed signal. So this computed is uh, derived reactive states. It means it will create a derived reactive state and automatically calculates when dependency is changed. That means no subscription or manual recalculation is not needed. Computed values are catched efficiently. Why I am saying all these things is we'll see now. So there is, I will explain the thing first. The count is already defined. So the count related increment and decrement we have already defined, right? So there is one more example which I have been thought of is double count. That means we are increasing and decreasing a count with one value. That means 1, 2, 3, 4, something like that, or 4, 3, 2, 1, something like that. But when I change that count value, the double count value also need to be changed without having any other subscription, without having any other emission of the value. Okay, so we will add this double count. So there is a double count variable which I have been defined. So that is a computed one, and then the logic which I wrote is this dot count into 2. That means we'll be counting. We'll be multiplicating the value, count value into 2. Okay, so that multiplication with 2 should happen when we bind that value with the double count. Also, if the count value is been updated. Now we'll execute this in browser. Okay, so I have been defined two things like a count 0 and double count 0, because initially it will be 0 only. So increasing the count 1. That double count value is also changing, increasing the count 2, 3, 6, 8, you see, with the double count value. So we have not done any larger number of lines of code. We just wrote one line of code with the computed. So this computed is also from Angular core with a new introduction. We'll see. So we have already seen this logic, the double count function which we called. So this will be depending on the count update. But whenever the count updates, this will render the double count value. Whenever the count upgrades in the sense updates, that means increment or decrement. So we'll see the next one. The next concept in signals is effects. So an effect runs whenever dependent signals changed. This is useful for side effects, and we'll see an example this one. So I wrote an effects method in constructor. Again, this I wrote some console.logs, but whenever there is an increment or decrement happened with the count variable, so there will be some console logs are happening. So which I wrote here. But in this effect, anything can happen. I mean, we can write an API call, or we can write any other some logic which is been depending upon this count value. Okay, there is some loader is there, suppose. So if the loader flag is being changed, then something will happen to the HTML, or something will happen to the value. So those values we can uh, write out here with the required respective logic. Simply I wrote count and double count only. We just need to display these two values in the console whenever there is a count update is being happened. So I am showing the same count value only, but we can do anything. See, initially count 0, double count 0, because constructor will be executed at first item. So then I'm incrementing the count. Again, it is coming count 1, double count 1. So we'll see. So here we have been passed. I mean, here we'll see 1, 1, 2, 2, 3, 3, because two consoles I have been passed count only. That's why we are seeing same value in the two console, repeating the count value only. If we see count, double count, and then count, double count, so the effect will be automatically triggered whenever there is a change in the count value. I mean, whenever there is an update in the count value. Okay, this is effect. So this effect will have multiple uh, use cases. That means API triggers we can do, logging, analytics tracking. Mainly, it will do the local storage synchronization. Because of these use cases, we can avoid overusing effects for state propagation. That means in the state propagation also we use effects. So over usage of API calls whenever there is an effect is been called. So for the state propagation, we can avoid effects there. And we'll see signals versus RxJS operators in a small comparison. Like signals is simple reactive state. RxJS is a powerful asynchronous streams. And then easier learning curve with signals we can see. So these are easy to learn. Advanced stream orchestration means, so there are many RxJS operators we can use in multiple use cases like switch map, merge map, fork join, combine letters. So this is some RxJS operators which we can see signals versus RxJS operators. We can do this one more video. And with the signals, it will support fine-grained UI updates. We'll see when to use signals. So it is a component state or a UI state. There are some counters involved. There are some toggles involved. There is some local state management system is in there with the application. We can use signals heavily. When to use RxJS? So because we had a conversation on the signals versus RxJS operators, I am explaining the comparison between signals and RxJS operators. So this RxJS operators we use for HTTP streams, then WebSockets, debouncing or throttling. So switch map and asynchronous coordination, as I have already told. And with a complex asynchronous workflows, we use it. So we can use signals and RxJS operators combinedly, because signals will not replace completely RxJS operators. So both work very well together. In the signals, we can use for local state. I am summarizing the content here. So signals reduce a boilerplate code. So introduce fine-grained reactivity. Best for local component state. RxJS remains powerful for asynchronous stream handling when compared with signals. I'm not saying Rx signals will replace RxJS operators, but RxJS is a powerful tool we can use. But it when it is powerful means when we are using asynchronous stream handling, then it is powerful. For the simple local UI state examples or UI renderings or toggles or any other local UI state variables also we are using RxJS operators means it will burden the app. That's what I'm saying finally. So signing off here. Thank you, Shivajonala.